class, in this video, we're going to be interpreting and analyzing the graphs of linear models. In this video, we're going to be working on exercise 6G, part 2. In order for us to interpret the information given from a linear graph or a linear equation, it is important for us to understand what does the slope and the y-intercept mean in practical terms. So when we're given the equation, we already know that the a value is going to represent the y-intercept, so that's the number by itself, and the b value, meaning the number in front of x or the letter, is going to represent our gradient. Typically in real world scenarios, your y-intercept is going to represent your initial value, whereas the slope actually tells us how much does something either increase or decreases as time passes by. So if we look at the example on the right hand side, I have provided both the equation as well as the graph that describes the growth of a plant over time. So if we look at this graph, we can clearly see that the initial height of the plant was going to be 5 centimeters. Now, in order for you to identify how much has the plant grown, typically you would need to find out what was the gradient in this case over here, but I've actually given you the equation. So we can clearly see that the slope in this case represents that the plant has grown at a constant rate of 6 centimeters per week, because that is the unit of our x-axis. This was a very simple example. Let's go through 2 more examples so that we have a better understanding of how to interpret information from a linear graph. So this example over here is the first example in your summary booklets. The question reads, water is pumped into a partially full tank. The graph gives the volume of water V in liters after T minutes. We can see that the very first 3 questions from this example are interpretation questions where we simply need to read off the graph to answer these questions. So part A reads how much water is in the tank at the start. It's essentially asking for the y-intercept value. So in this case over here, we can see that the water is going to be 200 liters initially. Part B reads how much water is in the tank after 10 minutes. So if we read off the graph over here, we can clearly see that the volume is going to be 1,200 liters. And for part C, how long does it take for it to fill to 2,000 liters? In this case over here, if we read off the graph again, the answer is going to be 18 minutes. So pretty straightforward. Now part D wants us to find out what is the equation of the line in terms of V and T. So remember that the general equation of a line is going to be represented in this particular format over here. But because we're not using the variables Y and X, we're now using V and T. I'm going to write it in this general formula over here. Now we already know what is our y-intercept value because we solved that in part A. Our y-intercept value was equal to 200. So I'm going to substitute 200 where A is going to be. So the last thing for us to do is to find out what is our slope, what is our b value, and our gradient can be determined by using this formula over here. And in order for us to use this formula, we need to know 2 coordinates that lie on the straight line. I've already got the first coordinate, which is our y-intercept. So I'm going to choose this coordinate over here that lies on the straight line. And after I've done that, I'm just going to label both coordinates as x1, y1, x2, y2 like so, and substitute the values in. So in this case, y2 minus y1 will be 400 minus 200. And then it will be over 2 minus 0. So if I simplify this, it's going to be equal to 200 divided by 2, which is the same thing as 100. So now that I've got my gradient value, I'm going to substitute it back into the equation. So it's going to be V is equal to 200 plus 100t. But please remember, because we're dealing with linear modeling, we should always specify what is our domain. So in this case over here, our domain is going to be from 0 to 18 minutes. So I'm going to write it like this. For part E, we need to use the equation to calculate the volume of the water in the tank after 15 minutes. So what we're going to do is we're going to substitute T is equal to 15 into the equation to find the volume. So if we substitute T is equal to 15 into the equation, we know that 100 times 15 is essentially going to be 1,500, and 200 plus that is going to be equal to 1,700 liters. And lastly, for part F, it's asking at what rate is the water pumped into the tank. In other words, what is the gradient? So essentially, the answer of this question is going to be equal to 100 liters per minute. And make sure that you do include units in your final answer. Let's now look at the very last example. So in this example over here, the context is talking about a car depreciating its value over time. And part A wants us to find out what was the initial value of the car when it was new. So again, all we need to do is read off the graph for an interpretation question. So we can see that the value of the car is going to cost $27,500. For part B, it's asking what was the value of the car when it was 5 years old. So again, reading off the graph over here, the value of the car is going to cost $15,000. For part C, it wants us to find out the equation of the line in terms of V and T. So again, because we're trying to find out the equation, I'm going to write it as V equals to A plus BT. And we already know what is our A value, our initial value. So that value is going to be equal to 27,500. And finally, all we need to do now is find out what is our gradient value. So in order for us to find out the gradient, we'll be using that formula over there. Y2 is going to be 15,000 minus 27,500 over 5 minus 0. So if I simplify that, this is going to be equal to negative 2,500. So that's going to be our gradient value. Now, typically, I would be finding out what is the domain after this as well, but that's going to be asked in part E, so I'll do that afterwards. For part D, it's asking at what rate does the value of the car depreciate with time. So essentially, it's asking us for the gradient. So all we need to do is just interpret our gradient value. So therefore, it's going to decrease by $2,500 per year. And lastly, for part E, it's asking when does the equation predict the car will have no value whatsoever? So in other words, what is the x-intercept? To answer this question, we will substitute V is equal to 0 into the equation. So if you do that, your equation should look like this. We're going to solve for T, so let's move the 27,500 to the other side. So we'll subtract both sides by that value over there. In doing so, this is what your equation should now look like. And to get rid of the negative 2,500, we'll divide both sides by it. And therefore, T is going to be equal to 11 years. So it'll take 11 years for the car to have no value whatsoever. And because that is our x-intercept, therefore, when I'm writing my domain for part C earlier on, I'm going to write it like this because the linear relationship will only hold true or be valid from 0 to 11 years. You can't go more than that because after that, that would imply that the value of the car will be a negative value, which doesn't have any meaning at all in real life terms. So what I'd like you to do now is I'd like you to please answer the following 3 questions from exercise 6G part 2. This is the end of the video. Hopefully the video has helped you. Thank you for watching and I'll see you guys again in the next one. Bye.